Hey everybody, we're done with part A of the 2016 midterms. Let's move on to part B. It says we want to write down the firm's profit function and derive the first order conditions on W and R. Alright, the only tricky thing here is to remember that one, we have a production function, which is a little funky, because you see you have the X, like technology, and you might think this is like an augmented technology, or sorry, an augmented labor function, but notice that it's not with the L. It's just kind of off by itself. So we can't actually build a k-hat. We're just going to have to go with the standard little k. And the other thing is that they pay sales tax tau. So let's do it. We're going to start by writing down what we know, which is that the production function is equal to x times k alpha times L1 minus alpha. And we know that the firms will pay tau of their output in sales tax. So let's convert it to the little k form. So 1 over L of f is going to be x little k alpha. And we just cancel the L by splitting, right? When you divide x k alpha L1 minus alpha, we'll write the L as L alpha L1 minus alpha. So that cancels. And then just like the other question we did, we'll move the L to the other side. So we'll have L x k alpha. Great, so that's what we'll substitute into the profit function. So the basic profit function is going to be 1 minus tau. This is the amount that they keep for their profit of their output, times f, minus the wage they pay workers and the interest they pay on the capital they use. And we know that the rate of capital is going to be depreciation plus the rental cost. So let's substitute. We found that f is equal to this, so we can rewrite pi is 1 minus tau, and then Lx script k alpha minus WL minus delta plus R k. And our two first order conditions are that partial pi over partial capital equals 0, and partial pi over partial labor equals 0 as well. So we'll start with capital. So the derivative of pi with respect to capital, dk equals 0, implies that 1 minus tau. Now here we have a k, so we'll have alpha Lx k alpha minus 1, but remember that k is also little k. This is a inside-outside situation because little k has a big K inside, and we're doing derivative with respect to big K. So chain rule gives us a 1 over L. And then WL goes away, and the K at the end goes away, so we'll have delta plus R. And set all that equal to 0. This L and this L will cancel, so we're going to get 1 minus tau alpha x k alpha minus 1 minus delta equals R. And that's our first optimization behavior of the firm. The second will be the partial pi partial L equals 0 here, which implies now this has two L's. Again, the K is K, big K over big L, so we have to use product rule and chain rule here. 1 minus tau, and then we'll do this L first, which just goes away. K alpha plus 1 minus tau again, and this time we'll do the K. K, whoops, let's add the alpha there. Alpha K alpha minus 1. Now inside K, this K over L, we need to take the derivative of this with respect to L, which is going to be equal to k over L squared, and that's negative. So on the end of that, we added k over L squared negative. And then minus w equals 0. Okay, so we can factor some stuff. We can factor the tau, that's easy, and the x, that's easy. And then we can also factor a k alpha. So 1 minus tau x k alpha, and that's going to be times. So here we just have 1, and on the other part we're going to have alpha, and then when we factor out k alpha from k alpha minus 1, that's going to be the same as k alpha minus 1 minus alpha, which is going to be k minus 1, which is equal to L over k. So let's just write it that way, L over k, and then that's also times L and times k over minus L squared. So this cancels with this, and both of these L's get cleaned up. We're just left with minus 1. So the final answer, which I'm out of space, let's write it up here, we're going to have, oh, and then a minus w equals 0. So we're going to have w equals 1 minus tau. And then over here, we're just left with 1 minus alpha. 1 minus alpha x k alpha. And that's it. That's the other one. Let me double check I didn't miss anything. 1 minus tau x k alpha and 1 minus alpha. Good. I'll see you for part C.